Okay. Hi, everyone. I'm Julie Paprocki. I'm an assistant professor in civil and environmental engineering over at UNH. So I'm specifically a geotechnical engineer, which basically means I get paid to play with soil all day long. And so my role in this is that I'm interested in measuring the soil properties of these different challenging environments, such as salt marshes, tidal flats, sand beaches, and the sort such as that. Specifically in civil engineering, for most engineering materials like concrete and steel, we can go to a manual and get the strength properties that we need. We can tell the plant we want to have concrete of this strength. We can have steel of this strength. However, for soils, we don't have that luxury. We have to actually go out and measure those because a lot of times they've been naturally placed and then they tend to have differences both spatially and with depth. And in a lot of northern climates, we've come to realize that there's a lot of differences in terms of the environmental factors as well, including things such as biological activity and things such as temperature changes and so on and so forth. So we're interested in understanding what those properties are and how to actually go about measuring them, because a lot of our traditional techniques that we use are very challenging to use in these difficult to measure environments. We can't go out and put heavy equipment on there to go measure how strong the soil is. So, and the reason why we want to do this is that this is something we've come to realize is a critical factor for understanding the erodibility and the movement of these soils, is understand how strong they are and understand not just how strong they are on the surface, but also what they look like with depth. So I just wanted to point out quickly here, I know somebody made a joke about this earlier today, that we would see a lot of maps like this. So this is my map related to this. We've been looking at 4 salt marsh sites this year, thanks to some help from some folks in this room. And they've been spread out along the Great Bay. And then we've also looked at some tidal flats along the Great Bay as well. I know technically Mass Cove isn't actually in the Great Bay system, but I'm including it on this map anyways. We've been looking at these since about 2020. And so we have some long-standing data related to this. So the first type of data that I use to be able to analyze information related to the soils is going to be remote sensing data. We call this synthetic aperture radar, or SAR. I'm not going to talk too much in depth about this because I could talk about this quite literally for hours. But basically what this is that you can have a satellite system orbiting the Earth, and then it sends down a radar wave to the ground, hits the ground, some of that data goes back up to the satellite and is recorded. And then we can use that to look at things such as soil type and elevations and bed morphologies and stuff like that. So I have 2 different images shown here. One is going to be a commercial image, which is going to be the one that is on, I'm really bad with my directions, but it's going to be on the right here. This is from a commercial satellite. We paid a lot of money to have this, but you can see that this has a portion of the Great Bay. We have other images that do have the entirety of the Great Bay system within it. And then the other image that I have shown here on the left is going to be a publicly available image. This is from the Sentinel satellite system, which there are multiple different Sentinel satellites. I use the Sentinel 1A, 1B, soon to be 1C and D. Hopefully those go online soon to be able to look at change that's occurring on different systems. So we're looking at things such as soil type and also change related to coastlines along the entire region. And what's really nice about that data is it's free and available, and I can actually get it whenever I want. The other type of data that we collect is from what we call a portable freefall penetrometer, which I figured would be fun for the interpreter to be able to spell that one out. But basically it looks like a torpedo. So if you ever see me walking around with it, no, it is not a bomb. It has a series of sensors inside of it, accelerometers. So when I drop it, it hits the soil. When it hits the soil, it eventually slows down. And so when it slows down, we can be able to take that data to be able to measure the strength of the material that's recorded from there. I just wanted to show 2 different example data sets here. It's really quick, I promise. So this is from the tidal flat that's located outside of Adams Point. So if you've ever been there at low tide, there is just a giant expanse of mud that's located there. We've been collecting data there since 2020, and we've also been looking at data over whole seasons. We'll be doing another set of measurements starting probably this spring and throughout the summer and next fall. But we can see here that we have pretty deep depths that we've recorded too, and we can see that we have fairly low strengths that are recorded here. Another set of measurements that I just quickly wanted to show here is that this is from here actually at Gibner, just down the road here at one of the high marshes. And we can see that we have much shallower penetrations, and then we also have much stronger strengths that we've recorded with this piece of equipment. So with this, we're hopefully going to be able to look at different sort of environmental factors that are going to be impacting both salt marshes and tidal flats. And then we're also going to be able to look at this at a wide range of different environments. So am I right on time? Perfect. Cool.